In this video, we're going to look at simple calorimetry calculations using the equation Q equals mc delta T. So Q is our heat energy, and we typically measure this in either joules or kilojoules. M is the mass, so of whatever is changing temperature. And this mass is going to be measured in either grams or kilograms. C is our specific heat capacity. And the specific heat capacity will be measured in joules per gram degrees Celsius or kilojoules per kilogram degrees Celsius. And then lastly, we have delta T, which is our change in temperature. And that's going to be measured in degrees Celsius. So change in temperature is always TF, so the final temperature, minus TI, the initial temperature, in degrees Celsius. So the first example we're going to look at is a simple calorimeter contains 250 milliliters of water. If the water is heated from 16.5 to 32.6 degrees Celsius, how much heat was absorbed? Listing all of our given information. So we need, just going to write the formula. So we have Q, M, C, and delta T. So Q assumption that 1 gram In our next example, we're going to be solving for initial temperature. So a 10-gram piece of copper was heated in a flame to a final temperature of 187.4 degrees Celsius. If the copper absorbed 660 joules of energy, what was the initial temperature? So we're again going to list all of our parts of the equation, so Q, M, C, and delta T. So we know that Q is 660 joules. The mass of our copper is 10.0 grams. The specific heat capacity of copper, you can look this up on page 3 of your data booklet. This is 3.85 joules per gram degrees Celsius. And the change in temperature is temperature is the first step of this equation. So our standard equation is Q equals mc delta T. Since we are going to be rearranging for delta T, we're going to divide both sides of that equation by mc. It's a change in temperature of 171.4 degrees Celsius. Change in temperature. Our next step is going to be to equal our final temperature minus our change. Swapped places for our initial and change in 87.4 degrees Celsius minus 171.4 degrees Celsius, and that gives us